Welcome to my tutorials on variant effect prediction with snpEff. So for this tutorial, we are going to look at bacterial variants. This is one of many episodes I'm making on bacterial variants, so you should always come back to this channel to watch more of such tutorials. Now, for this tutorial, you need to make sure that you have snpEff installed, and you should also have bcftools installed. I have tutorials that show how to set up these tools, so check the description box, you'll find links to those videos. Now, for snpEff, I will show you one approach in this tutorial. So if you're having a challenge, don't worry, I'll show you how to use that approach in this video. So what we are going to do next is to open our terminal and then start the exercise. Okay, I'm on the terminal now. So what I'm going to do next is to create a working directory, and then I will cd into it. So I'll say make the variant effects, and then I will cd into it. So that will be cd variant effects. Okay, now I'm going to download the snpEff binaries. So let's go to the download page. This is the page, and I will leave the link to this page in the description box. So here we are going to download the latest, so we will use this link here. So because I'm going to download on the terminal, I'll get a download link, but you can also click it. All right, so I'm going to get a download link. So I'll right click, and then I'll click on copy link. And then I'll move to the terminal, and then I will download it. So I'll say wget, and then I'll paste the link there. So let's execute this command. All right, so the file has been downloaded. It's a zip file. So after it has downloaded, we will extract the contents. Okay, the file has been downloaded. So let's do an ls. We are going to find it here. So now we are going to extract the contents. So I'll say unzip, and then I'll supply the file name. So let's execute this command. All right, so we can see the activity. Now we have extracted the contents. So I'll clear the screen first. I'll do an ls. I'm going to find the directory snpEff. So you can ls into it, and then you find some directories and files. All right, so we have our jar, we have this, we have this, we have all of these. All right, now let us do a quick test. So that's what I'm going to do. I'm going to run snpEff. This is a jar file, so that means I need a Java. All right, so the quickest way to check if you have Java is to type Java, and you can even say dash version like this. So let's execute this command. So I'll execute it, and then if you should have Java installed, then you have some information being displayed for you. All right. Alternatively, you can install snpEff using Anaconda or Mamba or Mycobacterium. All right, but just make sure to have Java installed, and then download the Java file. So this is a quick info about how to set snpEff on your system. Okay. So let's do this. Now we have snpEff downloaded. So let's also download the example data. All right. Now before we even download the example data, let's just do a quick test on snpEff. So I'll just say java-jar, and I'll say snpEff/snpEff.jar. All right. So if I do it, I'm going to get this text being displayed. So once we have this displayed, that means that everything is okay. So that's it. Now let's proceed. Let's clear the screen. Let's do an ls again, and then proceed. So what we are going to do next is to download the example data that we are going to use. So we can find the data here. Let's go to the web page and then see the example data. So this is the page, and I'll leave the link to this page in the description box. This is one of my GitHub repos, by the way. So with the data, we are dealing with a Mycobacterium ulcerans isolate. All right. So this data was generated using snp. So snp is used to call variants. All right. So when you have bacterial genome sequence, for example, which are haploid, you can use snp to call variant in such data sets. All right. So for variant calling, you also need a reference sequence. So this is the reference sequence that are used. So this reference sequence, you can find it in the NCBI database, but I renamed the session ID. So that is why I had to place that one here. So I'll like you to download this one instead of the one in the NCBI database. So I repeat again. So what I did with this one is that I renamed the session ID. So this one here, I renamed it. And so I have a slightly different name here. All right, so I wanted to use this file rather instead of using the one here. Okay, but the sequence is the same, the content is the same. The only difference is just the session IDs that I modify slightly. All right, so we will have to download these two files. All right, so I will start with this one, the snp data here. So to download, just click it, and then you'll be sent to another page, which is here. And then come to this side, raw. So when you come to raw, right click, and then go to copy link. And then move to the terminal. So let's move to the terminal to download the data. So on the terminal, I'll say wget, and then I'll paste the link there. So let's execute this command to download the file. Okay, the file has been downloaded. So you can do an ls just to confirm. So we have that here. So this is our VCF file. Let's also download the reference sequence. So I'll go back, and I'll come back to this side again, and then I'll click. Okay, again, let me say that the link to this page is in the description box. So click the FASTA file, and then you'll be sent to another page. And when you're here, come to raw, right click, copy the link, and then move to the terminal again, and then let's do this. Type wget and then paste the link there. So let's download this file also. All right, so it has been downloaded. So if you do an ls, you are going to find them there. So I want us to do this. Let's move the data we downloaded to another directory. So I'll do this. Let me just clear the screen. Let me do an ls first. I'll say make the data, and I'll move the VCF file there. So this one, as well as the reference sequence, I'll move all of them to data. Okay, so we have done it. So if I do an ls, I'll see my directory data, and then if I ls into it, I'm going to find my reference sequence. That's the FASTA file, and then the SNPs data itself. So now we can proceed. So let's clear the screen and continue. Okay, so let's ls into the data directory again to see the files. All right. Now, before I proceed, let me say that if you are going to run snpEff on your data sets, on your VCF files, then I advise that you first process your VCF files, select the high quality variants, and use those for the variant effect prediction. Okay, now let's proceed. Now what we are going to do next is to normalize the VCF file that I have here. It's a recommended practice to normalize and get our VCF line splitted so that each line contains information for just one variant. All right, so we are going to use BCF to do this. We will do this in 2 steps. So I'll start with the first step. So I'll say bcftools. I'll say norm. I'll say -m -both. And I'll say -o. That will be the output file. So that will be snips underscore AGY99 dot norm dot step1 dot VCF. So there's the output. Remember I said we are going to do this in 2 steps. So there's step 1. Now I have to specify the inputs. All right. So the inputs, that will be data slash snips underscore AGY99.VCF.gz. All right. So this is going to be the final command. Now you notice that here I did not specify the output directory as data. All right. Because I want to separate the original file from what we are going to generate. So let's proceed. So let's execute this command. Perfect. So we have done that. So if some lines were split, then you find that's here. So here it says total, split, realign, skipped. So total is this, and then this one's 0, 0, 0. That means that split, realign, skipped, there was nothing. Okay. So if you are using your own data set, then it's likely you may see some numbers here as well. All right. Now let's look at the second step. So we will still run bcftools norm. So I'll say bcftools norm, and this time I'll say -f, and I'll specify the reference sequence. So that'll be data / AGY99.FASTA. And then I'll specify the output. So that'll be -O, and I'll say snips underscore AGY99.norm.step2.bcf. Right, so the step 2, this file is what we are going to use for the downstream analysis. All right, you can also rename it, that's fine. Maybe you may want to say AGY99.normalize. That's also fine. So I think we should even use this name rather. So this is going to be the output name, all right, the final name, because this is the second step, which is the last step for the normalization process. So we now have our normalized VCF. Okay, now let's do this. Let's specify the input. So the input is going to be the outputs that we generated from step 1. So that means it's going to be this file here. All right, so this is going to be the input. So I'll have to specify. So I'll say snips underscore AGY99.norm.step1.bcf. All right, so now let's execute this command. Okay, so we have done that as well. So if you do an ls, we are going to find 2 BCF files. All right, so there's a step 1, and there's a step 2. So step 2, we said normalize the BCF because that's the final step for the normalization steps. All right, so this file is what we are going to use for the next activity. Okay, now let's proceed. So now we have done normalization, we have our output file, so it's now time for the variant effect prediction. So let's continue. Okay, so we will proceed. So I'll first clear the screen, and then I will continue. So with snpEff, it also has some databases that it uses for the variant effect prediction. And so what we are going to do is to check to see if the organism we are dealing with, okay, there's information available in snpEff. Okay, so we'll do that, and then we can proceed. So let's take a look at the file again. Let's do an ls. I just want to take a look at the initial files we downloaded. So I made mention that there's a Mycobacterium ulcerans isolate. Okay, so these are variants from that isolate. So with M ulcerans, the reference sequence is the AGY99 string, right? So what we need to do is to check the snpEff database to see if there's information for AGY99, right? And then we can just enter some additional commands to perform the variant effect prediction. So first of all, we need to list the databases that snpEff have. I repeat, first of all, we need to list the databases that snpEff has, and then we can proceed with the rest of the activity. So let's ls again. Remember, we extracted the contents of the zip file, the snpEff zip file. So the contents are here. So ls into it, and you see your jar file. So we are going to run the jar file. So to list the databases in snpEff, we say java-jar, and then you specify your jar file. So that's snpEff/snpEff.jar, and then you say databases. So let's execute this command. So once we do that, we have the databases being listed for us. So we have lots of them here. Okay, so we have listed them, but what we are interested in is our reference sequence. That's AGY99. Let me just display it again. What we are interested in is our AGY99 string. So we can record the same command, and this time we will add a pipe and we say grep. We bring our quotes and we can say AGY99 like this. So let's execute this command. So once we do that, we have the databases listed. By this time, we will look for information that contains AGY99. All right, so now we see this. Okay, it tells us that there's nothing there. All right, so here we can modify this name here, because sometimes because it's grep, we can have situations where the pattern we give is not there, but it may be there in a different format. And so what we are going to do is to reissue this command. This time we are going to ignore the cases. So anything AGY99 will be displayed. It doesn't matter whether it starts with a lowercase a or uppercase a. So I'll recall it, and this time I'll say -i, and I'll execute the command again. Perfect. So once I do that, you will see some hits coming up. All right. So you can see what is being displayed now. So here we have AG199. And so this means that the names in the databases do not start with an uppercase. All right. It starts with AG199. That is why this -i here is handy, because it helps us to also kind of streamline things. So now we see the information. So that means that snpEff has information for our reference sequence. Okay, the databases that snpEff has contains information for AG199. And so what we are going to do is to download this database, the database for our strain. I repeat, what we are going to do next is to download the database for our reference sequence, that's AGY99. All right, so I'll do this. Now this is the name. You can see the name here. So there's the name of the database. We have this. Okay, so this is what I used initially. So I'll use the same one here. The same name also here. Okay, so we have some information. So basically, this is the name of the database. Let me just put it this way. So I'll need to copy it because I'll use it later on. So I'll copy this name here, and then I'm going to do this. I'm now going to download the database. All right. Now let's clear the screen. Let's ls into snpEff. Okay, so we have our snpEff. All right. So what we are going to do is to download the database of interest. In this case, the database is this one here. Let's just do it. We are going to download the database for AGY99. And I have specified the name. Okay, I showed the name. So we are going to do that here. So to download the database in snpEff, we say java-jar, and then you specify the snpEff jar, and then you say download, and then you say -vin, and then you supply it with the name of the database. In this case, this is the name that we are going to use. All right. So now let's execute this command. So once we do that, snpEff will download the database for us and then configure. All right. So let's wait for everything to get done for us. Okay, so the database has been downloaded for us. So let's look at it. So let's clear the screen, and then let's ls. So the database will also be found in the snpEff directory. I repeat, the downloaded database will be found in the snpEff directory. All right, so the directory which has the jar file, that's where we are going to find it. So if I say ls snpEff, I'm going to find a directory called data. All right, so if I ls into that data, let's do it. ls snpEff /data. I'm going to find that database, which is this one here. So you can also ls into it. So I can say ls snpEff /data. Now I'll specify it's here. All right, so I'm going to find some stuffs here. Okay, so there's it. Okay, so now we have our final VCF file, which is here. We also have our database, which is here. We also have our snpEff jar, which is here. The jar file. So now we are ready to perform the variant effect prediction. Now, if I want to run snpEff to identify the variant effects, then you will need to also specify some options. And so let's take a look at the page which has those options as well as their descriptions. So this is the page, and I'll leave the link to this page in the description box. So here you can see options. We also have results, filter options. We have annotations options. We have generic options. We have database options. All right, so we have all these options. So depending on what you want, then you can specify the appropriate options. So for this tutorial, I'll show you an example command. Then you can come back to this page and check the meaning of those options. Okay, So let's get back to the terminal and then perform the variant effects prediction. Okay, so I'll clear the screen and continue. Okay, I am now going to perform the variant effect prediction. I'll do an ls to take a look at my final VCF file again. That'll be my inputs. I'll ls into the snpEff directory to see my jar file again. Now ls into the snpEff directory again to take a look at my database, which is here. So now I can proceed. So I'm going to run snpEff now. So I'll say java-jar, and then I'll specify snpEff jar. So there's the path. And then I'll specify the option. So I'll start with ANN, and then I'll say -no log. I'll say -no stats. I'll say -no downstream. I'll say -no upstream. I'll say -no utr. And then I'll also specify the config file. So there's the config file. All right. So I'll say -c snpEff / snpEff dot config, like this. And then I'll specify the output format. So it's -o VCF. Okay, so that means the output formats, the file that will be generated, it should be in a VCF format. And then I'll also specify the database. So that's this one here. So the database, we don't need to specify the full parts, just the name is fine. Okay. The needed information is in this config file, the one we specify. So we just need the name of the database, which is here. So I'll paste that here because the name is long. So I have it here. And now I'm going to specify the inputs. So the input is this one here. So I'll just do a copy and paste. And that is it. All right. You can also reduce the font size so that everything is on one line, and then you can review and then just revert back to the original size. All right. So this is the final command. So let's execute this command. Okay, so snpEff is doing this work now, so we can proceed. Okay, so it has been done. All right, but with snpEff, one of the challenges, so let me just say one of the errors that you may encounter is with this message here, error_chromosome_not found. Okay, so this happens a lot, and it has got to do with the names of the sequence in the database itself, and then the names of the sequence. So in this case, chromosome. So let me just go over again. So one of the common issues that happens when you are running snpEff is this one here, error chromosome not found. Okay, so this has got to do with the names of the chromosomes in the database and then in your VCF file. So if there are inconsistencies, then you have this message coming up. Okay, so we are going to resolve it. All right, so don't worry about it. But I just thought I will let us do this first test and then get this error message, and you can use that to resolve. So hopefully, if you get an error like that, then you'll be able to resolve it. So before we resolve, let's just clear the screen. Let's do an ls, and then you are likely to see that no file will be generated or no output will be generated. That's fine. Okay, we had some errors. So we are going to resolve the error that we got. That is the error chromosome not found. So, yeah, so to do that, let's look at the database, which is here. So let's ls into snpEff /data/ specify the name. All right, so we have that information. So what we need to do is to check the name of the chromosome. Okay, that's the sequence, the name that has been given in this database, and compare with what we have in our VCF file, and we'll be able to provide a solution to it. So that's what we are going to do next. All right, So what we are going to do is to examine these files, this and then this, to look at the name that was given to the chromosome. Okay. Now what you should notice that with M. ulcerans AG199, this strain has a plasmid and it also has a chromosome. All right. So we need to look at all those stuffs. Okay, so I will start with this one here. So there is sequence.bin. So I'll need to display the contents. All right. So to do that, I'll say zcats, and then I'll say snpEff slash data slash this slash sequence.bin. So let's execute this command. So this will give us some information. All right. So with the information, just look at the last few lines here, and then look at this one, for example. All right. So we have the information here. We also have this accession ID, this one here, and we also have this. All right. And we have this and this. Now, this one is a plasmid for AG199, the AG199 strain. But with the data we have, it's for the chromosome. The variants were identified on the chromosome. All right. So we need to also look at the name that was assigned to the chromosome, and then we can proceed with the issue. We can proceed with resolving the issue. All right. So now we have the plasmid, which is this one here. So if we had plasmids in the VCF file, then we would have also factored that in. But because we don't have plasmids, we can ignore this one. So what we are going to do next is to check this one also, because this one says sequence of chromosomes. So that means definitely what we are looking for will be here. All right. So we need to still do the zcats, then specify the file. And this time we say sequence dot chromosome dot bin, like this. So let's execute this command. Perfect. So we have executed it. So here, when we come to the example line, like this one here, you can see sequence, we can see this value 1, we can see this. And when we come here, we see chromosome, and we see the location, okay, or the position or the regions. Let me put it that way. Okay, so here we have this name here, chromosome. But if you take a look at the reference sequence, let me just do this. I'll do this again. Let me just do a head first. I think that will be better. So we have this. Now let me just open another tab, and that will be better. So let's take a look at our reference sequence. All right, so ls into data, we have this. So let's do a head data slash AGY99.FAST-A. So with the reference sequence, this is the accession ID. This is the name of the chromosome. All right. So we have this. So this same name is what has been indicated in the VCF, the original VCF, which is here. Of course, we process it, but the same information will be in those ones. But let's just focus on the original one here first. So I will also list the chromosome name that has been indicated here for the variants. So I'll use bcftools. So I'll say bcftools query-f. I bring a quote, I'll say percentage, I'll say chrome /n, like this. And then I'll specify the VCF file. That's the data /snips ag199.vcf.gc. Now, because we have lots of variants, I just want to display just one of them. So I'll just say head /n to, let me just say head, that's fine. Okay, so I have that here. So here we see the chromosome. So there's the accession ID. So this one matches what is in the reference sequence. All right. But when we come to the snpEff database, we don't see that. We rather see the name chromosome, which is here. Okay, so it is this differences. Okay, the difference in the names is what caused that error to be displayed, the error chromosome not found to display, because here we have this name here. So snpEff is expecting to see this name in the VCF file, right? The VCF file which we use, that's ls, this one here. Okay, so snpEff expects to see this one chromosome in this BCF file. Okay, it can't see it there. So this one, obviously, will have the same accession ID as here. Let me just do, I think that would be better so that we are all on the same page. So I'll just reissue that command again, but this time I'll just use the input so that, let me just do it here. I'll just use the inputs, that's normalize.bcf, do a head. All right, so we have that here. Okay, so there's it. So it's because of the differences. Here is chromosome, that's the text, the word chromosome. Here it's CP000325. And so this is what we have to resolve. Okay, so this is why we had that issue. I'm just repeating again. And so to resolve it, what we can do is to rename the chromosomes in our VCF file here, our inputs. Okay, so we have to rename it so that it has the same name as what is in the snpEff database. Okay, so we have to rename them. So we have to name the CP00325, rename it to chromosome like this. Okay, so that's what we're going. So that's the key to solving that issue. So with bcftools, it allows you to also rename chromosomes. I've covered that in another tutorial in detail, but I'm going to do a short demonstration here to show how to rename chromosomes. Okay, so this is what we are going to. Let's just clear the screen. Let's do an ls and then proceed. So we are going to rename the chromosomes. So to rename, we need to create a text file that has the name, the old name, the name that we are going to remove, and we also need to specify the new name. All right, so in this case, let me just go over this. So in this case, this becomes the old name, and then this becomes our new name. So we will create a text file and then do that. Okay, so I'll just do a copy of this one here. And I'll say nano new name.txt. So I'm opening a text file. I prefer to use nano, but I can use Vim or any text editor. That's fine. So nano new name.txt, and then in it I'll paste the old name, space, and then I'll come and paste the new name here. I'll copy and paste it here. All right. So now we have that done. So now we can edit and save the changes. Okay. So if we save the changes, we can do an ls to take a look at the text file. You can do a cut to display it. That is fine. Okay. And now we are going to call bcftools and then let's do the renaming. That's what we are going to do next. So let's just proceed. Let's do an ls again and then proceed. So we are going to rename the chromosomes in this bcf file. So the information is available here. That's new name.txt. Let me just do a cut to see it again. So currently this is what we have in the bcf file. So we are going to change all the occurrences of this to this one here. So we will use bcftools, and to do that we will say bcftools. Now say annotate. Now says dash rename -chr s like this. So bcftools annotate -rename -chrs. That means we are renaming the chromosomes, and then we specify the text file which has the information, which is new name.txt. So that will be new name.txt, and then I will specify the output formats. Okay, so I will say -o. In fact, I don't even need to do that, okay, because when we don't specify an output format, then the default format is bcf. If you want a separate, or if you want a different output format, then you can specify the -o. But for this tutorial, let's just keep it with the default format, which is bcf file. Okay, bcf format. So I will leave it as it is. But if you want to change it, then you can just say -o-z. That will save it as a bcf.gz. But let's just remove that. Let's keep it very simple. So we have bcftools annotate -rename.chrs, and then we supply it with a text file which has the information, and then we specify the inputs as well as the outputs. All right. Now I will start with the output first. I'll say -o, and I'll say snips underscore AGY99 dot normalize dot renamed dot bcf. All right. So this is going to be the output file. Remember, we have normalize, and I've added this information, rename. So this tells us that it's normalized, but we have renamed something in it. I always try to add some information to my file so that anyone looking at it will have an idea of what the file is. Okay, now let's specify the input file, and that's going to be this one here. So I'll just do a copy and paste. I can just type. So I'll say snips normalize.bcf like this. Okay, so this becomes the final file. All right. Let me just reduce the font size a bit so that we can have them in the same line, or yeah, on the same line. Okay, so this becomes the final command to rename the chromosomes. All right, so that's what I thought I would let you know. So now we can execute this command. I'll revert back to the first side. Okay, so now let's execute this command to rename the chromosomes. Perfect, so we have done that. Okay, so the chromosomes have been renamed. Now before we confirm, let's do an ls to see the output file. That is this one here. And so what we are going to do is to now run bcftools query to take a look at this file and then display the chromosome names. So I'll say bcftools, and then I'll say query -f. I'll bring my quotes. I'll say percentage /n, and then I'll specify the file, which is snips normalize.renamed. I'll just say head. Now execute the command. Now you can see that what the chromosomes have been renamed to this one here. All right. Okay. Now, if let's say you don't see the word chromosome in that database, then you have to use the appropriate names. Okay, so it's the same format. So take note of that. All right. So now we have this one. So this one matches what is here. All right. So now we can rerun snpEff, and then we are sure to get what we want. Okay. So this is what I want to do. I'm now going to rerun snpEff again, and then get the command. Okay, running. So I repeat, I'm now going to rerun snpEff and then get my variant effects predicted for me. Okay, so I'll clear the screen. I'll just do an ls just to check my stats again, and then I'll recall that command. Okay, the one we use. So if you want to recall a command, just use the up arrow on your keyboard, and then just press it until you get to the command. So you don't need to type everything again. So we are going to rerun, but this time we have to change the inputs because we now have this one here. This is what we are going to use. So I'll need to clear this one here and then supply it with this one here. So that's a snips normalize.renamed.bcf. So this becomes our new inputs. So this is what we are going to use now. So let's execute this command. Okay, perfect. So now it's been done. So now you can see that snpEff is working nicely. So far, you have not seen any error. Everything has been done. So you can see that the variant effects have been predicted for us. So you can see all of them here. All right. So that's how we do. So now let's clear the screen. Let's do an ls. Now, if you take a look at what we've done here, we did not specify any outputs. Okay, and so what's going to happen is that everything will just be displayed for us like we did see. Let me just rerun it again. There's the command, all right? So let's just rerun it again. So we have it here. Of course, there's the command. We can see the output being displayed for us. But what we need to do is to redirect everything to an output file. Okay, so that is what was missing in the command that we are using, or that's what is missing in the command we are using now. So what we are going to do is to add something else so that the output here is directed to a file, an output file to the specifics. So let's clear the screen, and then let's record the command, and this time let's add this, and then let's proceed. So I'll add an output file here. So with the output, I can just say snips underscore AGY99. Maybe I can say an.bcf. Right, so let's just keep it simple like this. So I'll execute this command, and then once I do that, snpEff will do its work, and then the output will be saved in this file. So now if I do an ls, I'm going to find that file here. Okay, so I can just, let's just say head, because it's a simple text file, it's a text file. Let me just put it that way. Okay, to see some stuff like this. Okay, so it's a bcf, but it has annotations. Okay, so you can explore further with this. There are several tools available that you can use to view the annotations. You can read them in Python or R or other command line tools. All right, but that's something that I'll cover in another tutorial. So for now, let's do this. Now with the variant effect prediction, what we also want to do is to get the predictions, okay, in another file so that we can view. So with snpEff, you can generate an HTML file which has the information we call the summary file. And so we can add that. Now, if you take a look at our command here, okay, we set no stats, this one here. So that is why that HTML file was not generated. So we can generate that by removing this flag, no stats. So you can do that here. So I'll just do this and remove it. So if I remove it, let's run snpEff again, and let's see what comes up. So I'll do that again, and then you will wait for everything to get done for us. So now if I do an ls, it's done by the way. So if I do an ls, I'm going to find an HTML file here, snpEff underscore sound.html. All right. So you can also specify a file name that will be used, but we use the default name. So that is why we do not specify any other information. All right. So this one here, we can view it with our browser because it's an HTML file. I repeat, this output file here, we can view with our browser because it's an HTML file. So let's even do that now. So I'll open it now. So this is the HTML file. So you can open it, and then you have some stuffs here. So you have this HTML file. So we have different sections here. Then you can check them out. Now, a description of the output files can be found on the snpEff documentation page, which is here. I'll leave a link to this page in the description box. So I think this is going to be helpful for you to interpret your outputs. All right, so we have a lot of stuffs here that you will need to read. Okay, so interpretation and stuffs, that one depends on what you want to do, but in general, the description here is going to help you to interpret your results or to prepare reports or whatever, or to understand your data. Okay, so that one, it's up to you to look at. Now, we also have another output file, which is here, snpEff.txt. So you can open that. Okay, so this is it. Okay, it's a text file. You can also open it with a spreadsheet software, by the way. Okay, so I can do that. Let me do that here. Okay, so this is the outputs. So we have everything here. So we have our gene name, gene ID, transcript, biotype, variants, impact high, etc. So you have all this information. All right, so everything has been given here for you. It has been indicated nicely for you. So now with the snpEff variance effect prediction, it's possible to aggregate them into another table format. And so that's where snpE comes in handy. Okay, let's just go to snpE. Let me just open it here. So snpE, this particular one here, this tool here, is used to identify variants in bacterial genomes. Okay, but with snpE, what it does is that it aggregates reports from different tools, including snpEff, and then you can use that for your downstream analysis. So with snpEff, if you use snpE to call the variants, it performs the annotation with snpEff, and then you can have a table which has the variants as well as the effects and some other information. So if you use snpE, then you don't need to run snpEff yourself again. snpE will automatically do everything and then let you have the output. So we can look at an example output for snpE here. Let's just take a look at one for here. So let's take a look at an example output here with snpE. So we have this CSV file here which has the information. So when you open it, let's open it to a spreadsheet software. So when you open it, you have the variants, you have the products here, you also have effects. Yeah, this one here, this is done by snpEff. So snpE aggregates all the information and places them in a file, a single file, and you can view it to a spreadsheet software, and you can also perform your downstream analysis. All right, so if you are dealing with bacterial genomes, for example, then you can use snpE to call the variants, and then snpE will automatically run snpEff and aggregate all the reports for you. So that one, you don't need to do that yourself. Okay, so that's it. So let's get back to our outputs. I had that here. So this is the outputs. Okay, so this is for just one sample. Okay, so once you have it, you can just look at the report. You can also click on each of them to see what has been given, and then just use that to interpret your data. Okay, so this is it for variant effect prediction using snpEff. Now I will make more tutorials on that, and sometimes to what happens is you may want to also build your custom database, and it's something that I'm going to cover. So once I'm done with that, I'm also going to show that right here. So come back to this channel and then watch some more. And if you're also interested in supporting this channel, then you can always buy me a coffee. There's a link in the description box that you can use to buy me a coffee. So I'll see you in the next session.